Wonderful. Thanks, Jeremy. Good afternoon, everyone, and thanks to the organizers for having me. As mentioned, I'm one of the co-directors of the FloodNet project. We are a collaborative project between researchers at NYU, at the City University of New York, and with personnel at a number of different New York City agencies. And we're working to measure hyperlocal street-level flooding across New York City and do it in real time. And the motivation behind this work is that before we started FloodNet, we realized that there was no quantitative data available on street level flooding in New York City. And I know this is a challenge for many municipalities around the world. There also wasn't any real-time data on where flooding was happening and to what severity. And so with that in mind, next slide. We started FloodNet. The three goals of FloodNet are one, to design, build, and deploy low-cost sensors across New York. We also have developed networking infrastructure and data analysis pipelines to produce a number of data products that we use to communicate this flood data to our stakeholders. And our three stakeholder classes that we focus most on are community residents, city agency folks, and researchers who are working in the street level flooding space. And we do a lot of community engagement. It's really important for our project, one, to make sure that the data that were collected are actually useful. Data is not valuable unless it can be used and it's meaningful. We also talk to our stakeholders quite a lot to get feedback for improving the project as we go. The photo on here is a version of our sensor. It is an ultrasonic sensor. So we release an ultrasonic pulse. It goes down to the surface below the sensor, bounces back. We measure the time of flight. And because we know the speed of ultrasound, we're able to calculate the distance. And then if you can imagine, as floodwaters come up, that distance shrinks. And so we're able to calculate flood depth that way. All of the sensors transmit data wirelessly, either through cellular network or LoRa. And they're solar powered. We have a battery, and that allows us to have flexibility in where they go, where they're installed, because we don't have to plug them in. Next slide. I also should mention we collect data every single minute. So every minute we send that ultrasound pulse, and we're able to measure depth of flooding if there is any. We install these sensors on street infrastructure. The infrastructure we're using for the most part right now are these U-channel posts that are used for street signs, like no parking signs and stop signs, et cetera. We've been really lucky to have a partnership with the New York City DOT, who's allowed us and given us the permission to put our sensors on these posts. That's important because one of the bottlenecks of this work can be where to actually install the sensors and how to get permission. So we're very grateful for that partnership. The sensor you see here, for example, is measuring flooding that's going to happen right on the sidewalk below. That's an important thing to note, is that if the infrastructure is on the sidewalk, we do have to wait for floodwaters to come over the curb before we start to measure those waters. In addition, every sensor has a sign that we put up, and that's part of our community engagement program. So there's information about what that sensor is, where to find information, where to find data, and also that there's no identifying information that's collected. Next, please. So we currently have 265 sensors installed around New York City. Our number one funder right now is the New York City Department of Environmental Protection, and our current contract with them has us with a goal of installing 500 by 2027. So we have we're in quite a bit of a deployment mode right now to make sure we meet that target. Once the sensors collect data, and they send it wirelessly, it goes through our data processing pipelines, and then in close to real time goes up on our public-facing dashboard. And so there's a screenshot on here of what our dashboard looks like. Every dot is a sensor. It's a little hard to see here, but there's a number inside every blue circle, and that is the depth of flooding at that moment. So when I took this screenshot, we had no flooding around the city, which was a good thing. Can you go to the next slide? If you click on one of those dots, we'll get to see is first a kind of just a snapshot of the past 2 days of flooding. And then if you click on that explore data, you'll come to here, which is our data view page. And that allows folks, one, to see real-time data as it comes in, but also to explore all the data that's been collected at that sensor over time. Next slide. So I'm going to come back here to our data view page to start giving examples of what our data looks like. So the first example I want to give was a flood event that occurred on September 29th, 2023. We had a really high intensity precipitation event that came through New York during commute hours. And the image you see on the right is a snapshot from my cell phone. And there's fewer dots there because a year and a half ago, we had fewer sensors up. But what you can see is those sensor icons change color and the depths start to show up as we have flooding in those locations. The 32 you see there corresponds to 32 inches of floodwater above the sidewalk. If you go to the next slide, what we'll see is images of that location. So that's the Gowanus neighborhood in Brooklyn, the intersection of Carroll Street and 4th Avenue. It's quite notorious for flooding. And whenever there's a high precipitation event in the area, we often see quite big depths of floodwaters in that location. If you click on the next slide, what I'm showing in those red circles are actual two views of the same sensor that are located on that corner. And what you see on the right side, if you can go back, okay, great, is the data view page for that event. And so the black line is the sensor reading, so that's the flood profile. The green is the rainfall intensity. And one thing that's nice about having measurements that are collected every single minute is that we have a high resolution flood profile. You can see that at the start of the event, floodwaters accumulated quite rapidly, which can be a big public safety concern. We peaked at a depth of 36 inches in that location. As the rain started to abate, we started to have drainage, as you can see, but when we had another cloudburst, floodwaters increased again. And this can be quite useful for those that are doing flood modeling to have this sort of hyper local and high resolution data to be able to correlate the rainfall data with the inundation that we see. This data is also really important for emergency management. So if you can click on the next slide, one of the data products that we have is a flood alert. So when floodwaters in a location exceed 2 inches, and then our machine learning models that are our flood detection models have a high enough confidence that an event is a flood event and not noise, we send an email to our subscribing city agencies telling them, okay, there's a flood going on, and we give them a link that goes to this alerting dashboard where they can see all of the flood events that are happening at the same time in one page. And we've heard from some emergency management services departments that it's very useful for them because they may have limited resources and personnel to go out in a flood emergency, and they're trying to make a decision of where to deploy those resources. And having more data and more locations in the city helps them with that prioritization. Next slide. While I'm talking about data products, I'll also mention this. In addition to our data dashboard, we have a printable summary of flooding, which we call our neighborhood reports. We heard from some community members that one, some of their neighbors may not go online and may not be familiar with using a data dashboard. We also heard from others that they want to be able to go to community meetings or talk to elected officials with something in hand that's a summary of the flooding that's going on in their neighborhood. And so we produced this flood report summary in collaboration with community groups. Got a lot of feedback on what should go here. So in addition to our flood sensor data, we put 311 complaints that the city receives about flooding. Also photos that are submitted to the Community Flood Watch Project, which is another project where community members are asked to submit stories and photos of flooding so that we can help contextualize what does flooding actually look like on the ground. Next slide. So the other example I want to give of what our data can look like is focusing on coastal flooding, because in New York City, we're a harbor city. We have both stormwater related flooding, but also coastal flooding that occurs on a regular basis. I'm going to focus on Jamaica Bay, which is in the south part of the city. Next slide. Jamaica Bay is tidally influenced, and so the water levels go up and down with the tides. And something that I imagine a number of other people are aware of on this call is that during the full moon and the new moon, we tend to have higher high tides than usual other parts of the month. And that's because you have the Earth, the moon, and the sun in a line, and so you have gravitational forces on equal sides of the Earth, and so water bulges, and you have higher high tides than usual. Next slide. The example I'm going to give is from a residential block in Rockaway that's about one block from the bay. This is a photo of that street during a flood event. And what I'm showing in the data view is about a week's worth of data around a full moon. And so the tide data is in green, the flood data is in black, and the tide data we get from NOAA gauges. So thank you to our NOAA colleagues on the call. And what you can see is that when you have this 24-hour tidal cycle, having a higher than usual high tide, we have corresponding flooding at the street level. This block often will get flooding up to 1.5 or 2 feet during a full moon high tide. Next slide. If you zoom out, this is looking at 3 months of data. You can definitely see with this 3 months of data that actual cycle of the tides and the corresponding flooding that happens on this block. And I want to highlight again that this is a residential block, and there are community members who are faced every month, 24 hours, every 24 hours, with getting out of their home and onto the corner, kind of trudging through seawater. Next slide. One other example, thinking a little bit more transportation focused, looking at the Jamaican Bay neighborhoods. We're now going to look at the north side of the bay. If you can click to the next slide, focus on a community called Hamilton Beach. And that circle, that red circle, is an intersection to Hamilton Beach that is the one road in and out of the neighborhood. And that road is impacted by tidal flooding as well. And so we got asked by community members in that neighborhood if we could put a sensor there so they could know when is the road passable or not. So next slide. What this image shows is actually a photo from the New York Times showing that intersection. And if you look closely, it's a bit hard to see, but our sensor is on that street signpost. And so we have been told by folks who live here that they will check our public-facing dashboard to look at the real-time readings to know, can I go to the grocery store, or if they're out at work, should I wait an hour or two before floodwaters come down? Next slide. A couple other uses of our data for transportation. One thing I want to note, this is a new data set, and we are collaborating with the DOT, and we talked to our New York City DOT colleagues quite a bit, and I know there's some folks on this call about potential uses. These uses aren't systematic yet. I think we're trying them out to see how they work, given that this is a new data set that they haven't used before. But a couple things that have been mentioned as useful for the data are, one, assessing current and future flood risks on roadways as a data set for planning studies. So if a Department of Transportation is trying to figure out what new mitigation roadway improvements they want to do for flood mitigation, it's good to have data on what type of flooding, how often it's happening, depth that's happening currently. Informing road closures is important. And then also there's opportunities for rerouting traffic. So rerouting buses or other transportation modes if a road is flooded. Next slide. I'm going to give one concrete example of a collaboration we have with New York City DOT right now. This is Brookville Boulevard. It's close to Jamaica Bay. Next slide. It's in this circle, and it's a roadway that goes through a tidal marsh. So another roadway that's impacted by tidal flooding. This is an important transportation route for folks in the neighborhood around or in this region. It used to be a bus route as well, but the bus got discontinued because the roadway was flooding on a regular basis, and it became a bit of a challenge for the bus operation. In the orange is predicted tidal flooding from tides in 2050, and so you can see that this road is definitely impacted. And so the DOT, New York City DOT, got some funding to do a study to evaluate potential mitigation strategies for flooding on this roadway. And so we collaborated with them to install a number of sensors. And if you click to the next slide, we installed 3 sensors. This is an image of a member from our team and a member from the New York City DOT working together to put up one of the sensors in that marsh. For installations like this, we actually put the sensor inside a tube, so we don't have issues with plants getting in the way of our ultrasound pulse that's doing the measurement. One reason, and I should mention, these went up about a month or 2 ago, and so we're starting to have data come in and working with the DOT to help sort of think about what this data can mean for them. One reason why I wanted to bring up this installation is actually because of some of the challenges that we had in actually doing the installation. And so if you click to the next slide, one of the first days we scheduled to go out and do our installation, we forgot to check the tide chart. So we went out, and it happened to be close to a full moon. There was a high tide. And when our team got out there, they actually had to help some other folks that got stuck in that floodwater. And so it took 1 or 2 more attempts at installing before we were actually able to get our sensors up. But something to note is that as we're seeing tidal flooding impacting roadways across the city and across the nation, we're going to have to be checking tide charts in a way that maybe we hadn't before to do that road work. And one thing that's useful about these sensors, it can actually tell you in real time. You're not just looking, secondarily guessing what the tide means for your roadway. You can actually get data about what's happening on that road at that time and whether you can get your crew out to do the road work that needs to be done. Next slide. So one final slide is just to note a couple uses across the city, not just at the DOT. So these are uses that have been identified as potential future uses for the data. And as I mentioned, we're still figuring out what works and what doesn't and how we can best present the data to city agencies for these uses. But planning and designing of flood resiliency infrastructure across the board. We're also working with the New York City DEP to monitor the performance of some of this mitigation infrastructure that's been installed. As mentioned, emergency response and road closures. There's a lot of interest in the data for cataloging impacts of flooding on roadways and also pinpointing where to prioritize post-flood assistance. And as mentioned, new uses are going to emerge over time, we imagine. Next slide. I'm going to end here. I want to thank our team. Our website, I think, has been put in the chat. Also acknowledge our funding sources, especially the New York City Department of Environmental Protection and all of our community partners. And I look forward to questions. And I know it's a short question and answer session, so feel free to email me if you have more interest and questions after this seminar. Thank you.